Okay, so 12.3 is the dot product. Okay, so in the last section, we basically learned how to add and subtract vectors. Okay, and what a vector was. Okay, so this piece is going to show you how to multiply two vectors together. Okay, so the first thing that I'm going to do is I'm going to give you the formula, which is called the dot product. Okay, so you're going to write down dot product. Okay, here's the notation. They actually want you to write the little dot between the two vectors. So u dot v, they will always do a dot. So, what's that? It is. It's a very important dot. Okay, so you got u times v. So what do you notice is happening on that equation? First of all, is this a three-dimensional or a two-dimensional scenario? It's a three-dimensional scenario. Okay, so if you want, I could write this down. Maybe, I don't know. I always like my definitions better. Oops, dot. I forgot the word dot. Dot product. And I can't spell. Product. There we go. Okay, so let's say you have u. So u is generally composed of an x, a y, and a z, right? So if I have vector v, then we could call that x1 or x2, y2, z2. So the definition of dot product would be, what do you think? So using the variables that I just used, what would you say? What do you do to get the dot product? Good. Multiply the x's.
Multiply the y's.
Multiply the y's.
And multiply the z's.
And multiply the z's. And then add it all together. Okay. So let's do a very quick example of a dot product. So, by the way, since this is in three-dimensional space, what would the two-dimensional dot product look like? Yeah, like just take out the z's. Otherwise, it would be the same. Okay, so let's say I'll just do one with two-dimensional. So let's say our u is -3, 5, and our v is 4, -1. Okay, so which two numbers would I multiply first? Good, so -3 times 4, and then what other two numbers? 5 and -1. Okay, so some of you guys are jumping straight to it, which is totally fine. So we get -12 plus -5, which makes
-17.
-17. So this is kind of an interesting thing, that when I multiply two vectors together, I don't get another vector. Instead, I get a scalar, okay, or like a constant value. Okay, so interesting. And why do we care? Right? So turns out that you can use the dot product to find the angle between two vectors, which is really, really super awesome, because if I gave you two vectors and asked you to find the angle between them, you would have to add them up, find the resultant, find their magnitudes, and then use a potential law of cosines. Remember doing that? Way back when? And that's a lot of work. So instead, we're going to use the super awesome definition that they found for us. And actually, you can use that scenario to come up with this equation. But you're going to write down in your notes that the angle between two vectors is this formula. Okay, that second equation down below is literally the same exact definition, but just solve for the dot product piece. You probably would not use that in anything that I can think of off the top of my head. Okay, so pretty awesome that they came up with that. I guess we could have done that. We could have. Okay. Okay. Is it still working? Okay. Yeah, those pens are not very durable, I've found. But they're the cheapest ones that I can possibly find that actually work with the smart features.
Terrible.
What?
You just don't know the cheapest ones you can find.
Yeah, but do you know how much the cheapest ones are?
$2? $14.92.
The cheapest ones are $30. And they right now they're going 50, yeah.
Cheapest what?
Those styluses.
These are nice.
They are nice, but they're just not durable. They're not meant for school kids. No offense, child.
His hands are too sweaty. That's the problem.
Alright, you ready for an example?
It messes with the movie.
Do you want it? No, if it's still working, I want you to keep using it. Or
I personally don't use it. It's like dragging.
Alright, so we're going to do the definition. So we're going to find the angle between the two. Okay, so the first thing that we're going to do is find the dot product between the u and the v. Okay, so I'm just going to write this off to the side here. Okay, so notice that of course they give this to you in standard form, super awesome. What two numbers are we going to multiply together first?
I and J.
Okay, so 1 and 6, no jazz, no. I's together, J's together, K's. Okay, so now we're going to do our J's. So what two numbers do we multiply together next?
2 and 3.
Close, yep, -2 and 3. And then the last two? -2 and 2, good. Alright, so we get 6 minus 6 minus 4. So what is my dot product value? -4. Okay, then, if you look at that definition, we need to divide by the magnitude of v and the magnitude of u. So let's then find our magnitude of each piece. Okay, so how do I find the magnitude of u? The square root of what?
1 squared.
Good. Okay, so if we solve that, we get 1 plus 4 plus 4, which makes a square root of 9, and the square root of 9 makes 3. Good. Okay, and then we're going to find the magnitude of v. Okay, so how do we find magnitude of v? 6 squared plus 3 squared plus 2 squared. So that gives us 36 plus 9 plus 4. So 36 plus 9, 45, and 45 plus 4. The square root of 49 is 7. Ooh, nice little numbers. Just so you know, it'll be rare that you actually get magnitudes that break perfectly. It'll be more likely to have them be in radical form. Okay, so now we're going to go to the definition of our angle. So the angle was the inverse cosine of the dot product of the two vectors divided by their magnitudes, right? Okay, so we're just going to plug in the information that we just found. What did we get for the dot product value? -4 on the top, and then what two numbers are going to be multiplied on the bottom? 3 and 7. Alright, so your turn. Grab your calculator and tell me what the angle is that exists between these two vectors. 100.98 degrees. Now I would draw that for you, but this is a three-dimensional scenario, so it's going to be hard for me to actually draw that in three-dimensional for you to see. I could try. Would you like me to try? What'd you get?
Well, I know it's wrong. I know it's not.
Did you check your calculator's mode? Make sure you're in degrees. Alright, so angle between two vectors, check, piece of cake. Pretty easy. Alright, I have a word clue for you. Who's in word clues? Orthogonal. Does anybody know, is anybody in word clues? You are? Okay, so I guess you're our only word person. Does anybody know what ortho means?
Orthodontist.
Close.
Teeth.
No. Don is straight or correct. Correct. Straight or correct. Yeah.
Straight. Correct.
What do you think GON stands for? Okay, angles, yeah. Okay, so if we were referencing math, what do you think the correct angle in math would be?
90.
A 90-degree angle. So just so you know, orthogonal literally translates to perpendicular.
Well, you just gave me a pound, so that's what
I can't spell. Alright, so just so you know, to figure out if two vectors are perpendicular, all you would have to do is do a dot product, and if it equals 0, then you know that they are perpendicular, which is a pretty cool trick. Okay? So basically what is going to happen is they're going to give you two vectors, and they're going to say, are they orthogonal, are they parallel, or are they neither? So how would you decide if two vectors are parallel? Okay, what was my question? How do we know if two vectors are parallel? Okay, so think about in the past. One of you talked about two things that are parallel. What is the same? The slope. So if we're working with vectors, what do you think will be the same instead of the slope? What thing would represent the slope? Okay, so a vector has a magnitude and a direction. Remember, magnitude is the length. Do you think the lengths matter? The direction matters. So if the angles are the same, then they're parallel. Or if the angles are exactly opposite, right, then they're the same. So if one is 0 degrees and the other one is 100, 0 is not a good example. One is, 0 and 180, that would work. Right, those two things would be parallel. Okay, so supplementary or equivalent. Should we do an example? I feel like I should make one up. Ooh, I think the one that last class had was good. So are these ortho, parallel, or neither? I don't know example 3. So U, 9, -4, B, what did I have? 4, -9. Yeah, that sounds good. Okay, so the first thing we're going to test is see if they're orthogonal. Okay, so how do I test that? A quick dot product, should take no time at all. So, multiply the x's, you get 36, and if you multiply the y's, you get 36. So would you agree that those are orthogonal? They are not orthogonal. So no there. Okay, how are we going to find the directions? So what's the formula to find direction? Remember, it starts with a tan. Yep. So I got to find the direction of both vectors independently. So I'm going to do the angle of u. So that would be the inverse tan of y over x. Is everybody following me? Y over x. Okay, so can somebody type that in and tell me what you get? Anything? Anything? You gave up? Yeah, you were typing. You were vigorously typing. You got what? Negative 23.96, okay. Let's now find the angle of V, so that would be inverse tangent of what over what? Okay, so type that in, tell me what you get. 0.4. So, are those two directions the same? Are they 180 degrees difference? No. So are they parallel? No. So, therefore, they are in neither scenario. Okay, so they are not perpendicular and they are not parallel. That's all. Okay. I will tell you that there is some stuff on the worksheet that Oh, yeah, actually, that's true. But I'm going to show you. So, these are properties. I don't think you should write these down. Those properties are the same as algebra properties. Okay, if you add two vectors together or multiply them, they're commutative. You've seen all these formulas before, right? They're the same properties as when we were working with the adding and subtracting. Okay, but the one thing that I'm not going to go over, which I want to see if you can figure out on your own, is this piece right here. Okay, so this is projection. There's, I think, 2 questions on this worksheet regarding projection. Okay, so write down this formula, and I believe that just by using the formula, it'll be a piece of cake. It was like 4 examples.